Hi everybody, today we're going to talk about solving linear equations. So equations are going to be a little bit different than expressions that we talked about before. So equations are going to be things that we solve. When we did expressions, all we could do with expressions is simplify. So a lot of times I will tell you on equations we're going to solve, and so you're going to get x equals a number for the most part, or it could be y, it just depends on your variable, but variable equals a number on these. The first thing we'd like to do is to check solutions. So if I'm given an equation, notice all of these are going to have an equal sign in them. I've given an equation 3x plus 6 equals 0. I want to check the solution x equals negative 2. Now if I check the solution and I get a true statement, if I plug that number in, then that means yes, that is a solution. If I get a false statement, then that means that I do not have a solution. So let's look at this example. 3x plus 6 equals 0. If I want to say that I want to check x equals negative 2, I'm going to take a negative 2 and I'm going to put it in there for my x. So 3 times negative 2 plus 6, we're going to work that out and see if that equals 0. So 3 times negative 2, you know, you've got to do order of operations, so multiply first. That would be negative 6 plus 6 equals 0. Negative 6 plus 6 is 0. So 0 equals 0. That works. So yes, x equals negative 2 would be a solution. For this next one, I have x squared equals 16, and they want me to try x equals 4 and x equals negative 4. So if I try x equals 4, 4 squared equals 16. So 4 squared is 4 times 4. That equals 16. So that works. So that x equals 4 is a solution. X equals negative 4. Now you need to be careful when you put in negatives. Be sure you put those negatives in parentheses, and then whatever else operations are going on outside the parentheses, you just copy them over. In this case, I've got negative 4 in parentheses squared. So that means negative 4 times negative 4, just to remind you. And negative 4 times negative 4 does equal positive 16. So in this case, both of those checked. Alright, so now the next one, negative 12 over x equals 4. We're going to try x equals negative 3. So negative 12 over negative 3, does that equal a positive 4? Well, you know, when you divide, 12 divided by 3 is 4. And since I have a negative divided by a negative, that equals a positive. So 4 equals 4. That works. Now they're not going to work every single time. It just so happened in these examples they did. Alright, so determining whether equations are linear or nonlinear. Linear equations have an x to the 1 or a y to the 1. Nonlinear, they have higher exponents or a variable in the denominator of a fraction. I'm going to switch that down. So those would make things nonlinear. 3x plus 6, this would be linear because it is a 3x to the 1 plus 6. What nonlinear and linear means is that if we drew a graph, the graph would be a line. So if I drew the graph, which we're going to do in the following chapter, if I drew the graph for 3x plus 6 equals 0, I would have a line on my graph. X squared plus 6, or x squared equals 16, this one is nonlinear because I have a higher exponent than a 1 with my variable. If I graphed x squared equals 16 on a graph, I would have a curve. I would not have a line. Negative 12 over x equals 4. Again, this has a variable in the denominator, so this would be non-linear. So a linear equation in one variable is an equation that can be written in the form ax plus b equals c. That would be the general form of a linear equation. You have a variable with maybe some numbers along with it. Alright, so if we are going to look at these and state whether they're linear or nonlinear, again, if I have a 3x cubed, that's going to be nonlinear. If I have x equals 7 over 3, now on this one, the x is not in the denominator. This could be linear. It's got a fraction, but that's okay, as long as the x is not in the denominator of the fraction. Alright, now, let's talk about solving. When we're solving equations, our goal on solving equations is to have a variable equals a number. So we want to have a variable. So for example, we want to have x equals 5, y equals negative 2. That is our goal, okay? And in order to get that goal, we have to think about how do we make the side that's with the variable just have that variable. So we think about on these first ones, we are going to add or subtract to get the variable by itself. And it's not wanting to cooperate with me today. So I'm looking at t minus 5 equals negative 8. So in other words, I want to get the t by itself. So I've got a t minus 5. The opposite of a minus 5 is a plus 5. If I add on one side 5, I need to add 5 to the other side. Okay? Make sure if you add or subtract you need to make sure you do the operation that goes on both sides. Of the equal sign. So in other words, whatever you do to one side, you automatically do to the other. And in fact, I write it down before I even try to work anything out. I put it down on each side. So if I have minus 5 and a plus 5, that gives me a t. If I have negative 8 plus 5, negative 8 plus 5, that's opposite sign, so subtract and keep the sign of the larger. That would give me a negative 3. You can come down here and check them. If I check t minus 5 equals negative 8, and I'm saying that negative 3 is my answer, so negative 3 minus 5, does that equal negative 8? Negative 3 minus 5, that's two negatives. You add them and keep the negative sign. So negative 8 equals negative 8, that checks. Okay, let's look at the next example. C plus 12 equals 28. I have a C plus 12. The opposite of a plus 12 would be minus 12. That is the number that would cancel out that that 12 with the C. So those cancel out. So I have C equals 28 minus 12 is going to give me 16. If I want to come down here and check, I need to check to see the 16 plus 12 equal 28. And 28 equals 28. It works. So C equals 16 would be my answer. So what I've been doing when I have been adding or subtracting to both sides is I've been using the addition property of equality and the subtraction property of equality. So what they say is that if you've got A equals B, then you can take A plus C, that's going to be equal to B plus C. As long as I do the same thing on both sides. For subtraction, the same thing. If I have A minus C that equals b minus c. So as long as you keep your equation balanced, whatever you do to one side, you do the same thing to the other. So let's do some of these. And you're going to see you could have variables on the left side of the equal sign, or you could have variables on the right side of the equal sign. This one that's the number a on here, I've got 7 over 10 equals y minus 1/2. So I'm going to work with the side that has the variable. The opposite of a negative 1/2 would be positive 1/2. So I'm going to add, I'm going to add 1/2 to both sides. So over here the y is going to be by itself. Now I have to worry about figuring out 7 over 10 plus 1 over 2. Well, the common denominator would be 10. So 2 times 5 is 10. 1 times 5 is 5. 7 over 10 plus 5 over 10 gives me 12 over 10. I need to reduce that fraction because 2's go into both of those. So 2 goes into 12 6 times. 2 goes into 10 5 times. So 6 over 5 equals y. Same thing works if we're going to do decimals. If I've got negative 6.3 plus z equals 9.1, I'm working with the side of the z. It's a negative 6.3. The opposite would be positive 6.3. So I'm going to add 6.3 to both sides. Over 2 there, 6.3. So then those cancel. So z equals 9.1 plus 6.3 would be 15.4. Now, you can come down here and check those. I'm not going to go through the work of checking them, but you can go and check those problems and put in the values that we got and double check and make sure we got the right answers. Okay, at the bottom of the page, you can see on the left side, they've got negative 6 plus x equals 12. So they're doing theirs in a line. You will notice a lot of books will do theirs in a line. It's just always been my habit to do my equations and write them underneath. It is certainly up to you how you choose to do it. I've just always done it that way, so that's the way you'll see me do these on the videos. So if I've got negative 3 plus y equals 27, to cancel out negative 3, I'm going to add 3 to both sides. So I'm going to have y equals 27 plus 3 equals 30. And then I'm just going to check this one in my head. Negative 3 plus 30, does that equal 27? Well, if I've got a negative 3 plus 30, subtract and keep the sign of the larger, and I would get 27. Okay, moving right along. Multiplication and division property of equalities. Just the same as we added or subtracted to each side of the equation, you can also multiply or divide. So multiply or divide on both sides. Again, we want to get a 1, I'm going to say x, but it could be y, it could be z, whatever your variable is, you want a 1 of those. So if I've got 5x equals 40, I want to think about how can I make that 5x into a 1x? Well, it's 5 times x, so the opposite of multiply is what? Is to divide. So if I want to cancel out the 5 that's in front of that x, I could divide both sides by 5. Remember, whatever I do to one side, I do the other. Those 5's would cancel, so x equals 40 divided by 5 is 8. So I'm going to say the answer is 8. To check it, I could come over here and I could say, well, does 5 times 8 equal 40? And 5 times 8 does equal 40. So that means that I have gotten the right answer. 24 equals negative 2 divided by y. So you could have a negative in these. If you have a negative, in order to get a positive, you would also divide by a negative. Because remember, dividing and multiplying, if you have the same sign, you get positive answers. So I'm going to divide on this one by negative 2 on both sides. Now be sure you don't make the mistake and think that's 24 minus 2. That's 24 divided by negative 2, which would give me negative 12. So if I want to check it, does 24 equal negative 2 times negative 12? And 2 negatives would give me the positive that I need. So 24 equals 24, that works. Now, on this next one, I have negative w equals 7. What you have to do is remember that if you don't have a number in front of your variable, there's an automatic 1 there. So this is really negative 1w equals 7. If we follow the same rule as above, I divide both sides by negative 1. So w equals negative 7. 7 divided by negative 1. So if I'm checking that, does negative a negative 7 equal 7? Well, double negatives would cancel each other out and give me positive 7. So 7 equals 7, that works. So here are the rules that we've been using. Multiplication property of equality and the division property of equality. So multiplication property says that I can take A times C and that would equal B times C. The division property says I can divide both sides as long as I divide both sides by the same number. I'm good to go. At the bottom of the page, I've got negative 3w equals negative 15. I'm going to divide both sides by, what do you think? You should be thinking negative 3. So then the two negative 3's would cancel and I would have a w. A negative 15 divided by a negative 3 would give me positive 5. Alright, moving right along. Here we have some fractions to practice. So if we want to if we have one fraction equals one fraction, we can cancel out a fraction by multiplying by the reciprocal. Now, in a later chapter, you're going to learn how to clear fractions from equations, and by all means, if you find that way easier on these shorter ones, you may do so. But on these beginning ones, if you just have one fraction with a variable equals one other either number or fraction, then you can just multiply straight by the reciprocal. So if I've got negative 5 over 6x, and I want to cancel that out, I could multiply by negative 6 over 5. So if I multiply by negative 6 over 5 on one side, I'm going to come over here and do that on the other. So over here you can see the 6's would cancel, the 5's would cancel, negative 1 times negative 1 would give me positive x. That's what I'm looking for. So then we just need to work out the right hand side. Can't do any cross canceling with 4 and 5, but 6 and 15, 3 goes into both of those. 3 goes into 15 5 times, 3 goes into 6 2 times. So that makes my problem a little bit easier. 4 times negative 2 would give me negative 8. 5 times 5 would give me negative 25. Now if I want to come over here and check that, I'm going to have negative 5 over 6 times negative 8 over 25. We're going to see if that equals 4 over 15 when we do our cross canceling. 5 goes into itself one time, 5 goes into 25 5 times. On 6 and 8, 2 goes into 6 3 times, 2 goes into 8 4 times. Negative 1 times negative 4 gives me positive 4. 3 times 5 gives me 15, and you can see I end up with what I'm looking for, 4 over 15. So I know that my answer, negative 8 over 25, is correct. Okay, let's look at the one on the middle. And this time our variable's on the right-hand side of the equal sign. Again, it doesn't matter. Since I have one fraction equals something else, I'm going to multiply by the reciprocal. So in this case, 3 over 2 would be multiplying by 2/3 on each side. So these would cancel, and I just have a b, and I need to work out the right hand side. This time 3 goes into itself one time, 3 goes into 15 5 times. I don't have anything to do with 2 and 11, so 2 times negative 5 would be negative 10 over 1 times 11 is 11. We can do decimals the same way. I work with the side that has the variable, and this one I'm going to divide by negative 8.5. Negative 8.5. So I'm going to take negative 22.1 and I'm going to divide that by negative 8.5, and I get a positive because it's a negative divided by a negative. Positive 2.6 equals my y. Now this one at the bottom looks a little different. If you want to think of it this way, that's a 1m over 4. equals the 12. This is the same as the ones that I did above, where you have one fraction equals a number. So I'm going to multiply by the reciprocal. The reciprocal of 1 over 4 is 4 over 1. So I'm going to multiply both sides by 4 over 1, which is really just 4. So on the left side, those would cancel, and I would have m equals 12 times 4 over 1, or 12 times 4 gives me 48. That one can be a little tricky because you need to remember there's a 1 in front of that 4, or in front of the m. This one is very similar. I've got a d on the bottom, so that's like having a 1 over negative 4. So I'm going to multiply by negative 4 over 1 on both sides. You don't have to put the 1 over there on the right side with the 5, but I'm going to do so just so you can see what I'm doing. The negative 4's we cancel. I have d equals 5 times negative 4 is negative 20. Just some phrases, if we need to do some phrases. Product of 2.5 and x equals 12. So the product means to multiply. So 2.5 and x equals 12. And then you would work that out by dividing both sides by 2.5. So 12 divided by 2.5 is going to be equal to 4.8. I'm just going to do a couple of these. Let's do this subtracted from. Remember, if you have subtracted from, I need to flip the order. So 14 subtracted from w, so I need to take w minus 14. 14 subtracted from w equals 6.2. So in this case, it's an addition or subtraction one, so I'm going to cancel out by adding 14 to both sides. Put the .0 there just kind of to keep my decimal straight. So that's going to be 20.2 when I add those together. So let's do the one at the bottom of the page. The sum of negative 6, so sum means to add. So negative 6 plus a number, I'm going to let it be x. You'll notice that if it doesn't give me a letter to use for a variable, I generally use x. So negative 6 plus x is 13. We need to solve it, so I'm working with the side that has the x. So the opposite of negative 6 is positive 6, so I'm going to add 6 to both sides. So x equals 13 plus 6 is 19. And so those are your basics of solving one-step equations. I hope you have a wonderful day.